Okay. So Haimwant is a GIS specialist who works at the Ministry of Natural Resources, and his let's say he's Geographic Information Systems, so of course he has to use software to deliver his work. And what I like about Haimwant's approach, which is not in the bio we gave you, which you all have on the flyer, is that he actually trained at the Redlands place, which makes the very prominent GIS and expensive GIS software. And then he came back together and he said, no, we can't afford it. We're not going to pirate it. We're going to find free open source options and use it. And so he's going to talk to us about free open source software in GIS. Remember, Geographic Information Systems also offers a lot of potential for us if we can get the data. Because anybody asked the question, we open data earlier, so we don't have police stations looking like near the river and things like that, and so on, right? But if you get in there, right? Okay, here one. Right,
so, thanks, Vidya. So, if you can't get the data, you could create the data. Right? So, my presentation is FOSS. It moves away from actually looking at GIS, but it's free and open source software where we are geo-enabling data. Right. So the big talk about I came in at the ending of the other presentation. There I was talking about open data and all those scenarios. But since 2011, the big thing in the world has been big data, because they used it to find Osama bin Laden, and so it became the biggest thing ever. But GIS has been around since the 18th century. Most of you don't know it, but it's actually from geography. And it's geography applied in IT, statistics, and everything that goes with it. Your basic data management. So I just want to get some terminology out there. When we talk about geospatial technology, there are various geospatial technology, which we call the GIS. Is one geospatial technology, that's Geographical Information Systems. We're talking about global navigation position systems. That's what all your smartphones has. Your GPSs, you call it GPSs, I call it navigation systems, because GPS is just one type of navigation system. Spatial data collection system, that's online and offline mobile data collection. That's how Google keep tabs on you. And remote sensing, that's how we monitor things from a distance away. So basically, I want to know what sort of deforestation rate. I don't go with a GPS or a paper and collect everywhere we have deforestation. I use a satellite imagery, or I use a LiDAR, or I use a drone, or I use radar. Those are geospatial technologies. And when we talk about data, data is anything that has, or geospatial data, anything that has a location. It could be your city, it could be where you're sitting. It could be anything that you could put in a Cartesian coordinate system, right? X and Y, all right? So why do organizations need to geo-enable their data? I'm going to talk about this first, and then we're going to talk about the free and open source software to geo-enable your data. Because most organizations need to visualize. Anybody knows the data, information, knowledge, and wisdom theory? Right? All right, cool. So we'll talk about that later. So the organization needs the capability to visualize, analyze, and leverage their data to improve efficiency and decision making. Now, every decision that is made, whether by a personal, a company, a government, etc., should be driven by data. Should be. Note my term. Should be. All right. So the new trend out there, as I spoke of earlier, big data is used to empower GIS. Why? Because everything starts from data, and data by itself is nothing. All right? I could have a number of data in my phone. If I cannot create relationships with them, it means nothing to anyone. So data is an item or an event out of context with no relation to things, so it's nothing. So we need to transfer data to information, we need to make that to knowledge, and that will drive wisdom. And GIS is the driving force behind that, because everything is related to everything else, but near things are more related to distant things. And that's where we come in and talk about terms of spatial autocorrelation and Moran's index. That's where the statisticians come in. All right, but you're applying statistics on a spatial level, which is totally different. All right, so if you think statistics was bad, doing it the normal mean, etc., doing spatial statistics is very different. All right. All right. So typical enterprise GIS. Coming to enterprise GIS talks about ingesting data into a system, somebody performing some processes onto that or processes, and then deliver products. all right? And it has its own architecture that basically has an authoring tier, that's the person's creating the data, to a serving, and then the consumer tier. The serving is basically talking about your servers, your type of delivery, if it's REST or SOAP, and your consumer tier, if you want to use your mobile maps on your phone, you want a desktop type of analysis system where you get dashboard type of analytics. And you're talking about content management front end. You're talking about emergency response. So it's actually taking the authoring of the data from the back end, which we normally do. I mean, everybody sits behind a computer here, right? Or should have or would have. And you write something in Word, even in Word. That's your authoring, you're creating content. But then you're moving it to an enterprise level, means that you're making your data distributable. Right? You're publishing it via a server. So you send it to Google. Let's say just use a simple Gmail. You're sending an email. You author it on your computer, you send it to Google servers, and then somebody else receives it. Right? So that's the simple logic behind it. Now, we're talking about, if we break down that architecture, that whole thing that we had here, is basically in an enterprise GIS format. We're talking about GIS software, spatial databases, internet map server, web server, and then you distribute your content across the internet. And that's basic architecture. Now, if a proprietary organization could do something like that and sell you it annually, you would have to pay millions of Ghana dollars for licensing for that. And if you have to buy it at the force up, it will cost you close to $1 million US. That there alone, that architecture for one organization. Now, if I am to implement that in my organization, of course, my PS would tell me no. And any organization here, they will look at, instead of geo-enabling their data, they will look at cost and just not do it. Okay? So if one is to just replace all of that now and just use free and open source software, that's your logic behind of it. We have free database, Postgres, leverage the Postgres extension, and we could even do routing. You want to go from one place to another. All that on your database. Whilst your authoring content could be done via QGIS, your remote sensing could be done via GRASS. I'm talking this, I'm just explaining the logic behind this. I know you guys are not spatial technologists or anything, but I'm just explaining how simply understanding the architecture, you could replace what you have within your system with free and open source components that is easily found up there. All right? So when you go to your server and publishing tier, we're talking about your internet, you could publish that on any one of these, or these are extensions of the same open source software and your internet map server, which is your internet server, which is Apache, which is free and open source. And you send that across the internet, which is consumed by any one of those free clients. So that there by itself is your entire architecture for delivering an enterprise GIS using free and open source software. And this has been done already. All right? So with my type of work, I come across many brilliant Guyanese talents. All right? They're very talented. And a group of guys that I recently worked with called themselves GeoIdeas. They created a platform called Digital Surveys, implementing the same enterprise level GIS on top of it. So the Digital Surveys platform is basically the same package that is there, bundled up with the set of the programming, and I mean, I'm a GIS specialist, those are the programmers, right? So what they did, they created a robust platform for applying the power of geography to workflows throughout an organization. So it's basically taking your cell phone or any mobile data collection device, collecting data, push it through a server, on or offline. You can have internet or not have internet. You collect your data in the field, whatever data you want, it goes to a server and comes to the front end already analyzed. The entire process using free and open source software. And for that, I want to give Owen credit. He's sitting right in the fourth row. So Owen is the guy behind that. So they're leveraging all these capabilities, applying this type of architecture. So you have server, you have online content, everything is mashed up via cloud service and it pushed up. The nice thing about it is that all your data doesn't have to, it uses the internet, but it doesn't have to be published through the internet. It could come into your phone, coming to a desktop type dashboard, which you just install on your computer, and you there sitting with your data. All right? So what I'm going to do, I'm going to just give you a demo of what the platform looks like. of one of their application, which is basically crime has been a big thing in Guyana. So getting crime statistics, someone tell me crime is down. I deal with location data. I want to know where. So coming from a discussion we had back in when we had the free and open source software day, was to how do we collect crime statistics or persons reporting using something called VGI, Volunteer Geographic Information System. So what these guys did, they actually built a platform, and this, now what I want to say is that whilst this application is used for collecting crime, the digital surveys platform could be used to collect any type of data. So if you want to use it in health, to monitor where persons are getting sick, and then correlate that with their environment, the type of water they're receiving, etc., you could leverage the digital surveys platform. If you want to do, if somebody from the agriculture sector wants to collect statistics on pests and diseases within the agriculture sector, they could leverage it. Anybody wants to collect any type of statistics that has a spatial component or even a non-spatial component could leverage this type of technology on top of it. And again, it's built on free and open source software right here by Guyanese, talented Guyanese. All right, so Crime Mapper. I mean, this site has a lot more to go with it. Right now, they're currently developing, hoping for when they have the exhibition coming the 19th, I think, they will have more on top of it. So what it does is that using our mobile phone, I have the application here. Just let me get my password. All right. So using one's mobile phone, when you open the app, it looks something like this, right? All you do, you just record a crime. All right, gives you some instruction. You record a crime, fill out a form, take a GPS point, and you just hit send. What happens is that it leaves your phone, it goes to the server, and then comes as a map on the front end. And what would happen in that case is that one could basically just get location-based statistics on what happened where. Now, as I said, this is coming in graphs and charts in the future. I mean, I think Owen, he was telling me that you just need to plug the microservices in and then dump the rest of the data onto this site, because we are using an HTTP before, so they're moving to HTTPS. So everything needs to migrate to a new server. So this is what's being done so far using free and open source software and leveraging the digital platform, digital service platform. Now, since we're talking about data, one of the things that I recently, I don't know how much of you heard about the Sustainable Development Goals for 2030. Ever heard of it? You ever heard of it? It's something that our country is supposed to be working towards, right? And heavily on this part is the component of spatial data. So if you leverage the digital survey platform, you could collect all the spatial data using mobile phones or tablet and integrate it into a system to better inform not only our country, but the world at large as to our sustainable development goals. Now, I'm not going to explain each one of these. There are 17 of them, right? Just letting you know out there that you could read about it and see how you could contribute more into making your country achieving these 2030 goals. All right. Again, if you want the app, also it's on Google Play. You download the Crime Mapper app. Just get it on your phone, and you see a crime, report it. You're helping everybody else. Because one of the things, knowing crime statistics, recently I heard an article out there that says Guyana is full of crime, and that's why we're not getting tourists. But at the Marriott, there's no crime. In Kingston, there's not high crime. That's where people come and go. When they go to Kiteshore, there's no crime there. When they go to Ogle, there's no crime there. So people, if you leverage location-based data on top of that, all right, persons will be better informed that, you know what, crime is not happening in places that I'm going to visit. So I should come to Guyana, all right? Also, just imagine the police leveraging such a platform. In spatial planning, in their spatial planning, how do they know where to set up the next roadblock, where the accidents are occurring? They know vaguely, but this helps them more. All right, I think video is showing me that that's my time. So if there's anything else to start.